Hi students, today we study about the thermodynamic potentials. Before that, let's learn about the syllabus of paper 7. There are 2 units in this paper. In each unit, 2 topics we will study. In first unit, first topic is thermodynamic potentials and second one is theory of radiation. Then in unit second, first topic is classical statistics and second one is quantum statistics. From your syllabus, quantum statistics will be deleted. So, in this paper, we will study about the 4 topics, only 3 topics: thermodynamic potentials, theory of radiation, and classical statistics. Now, we start our first topic, thermodynamic potentials. So, first of all, I introduce you about the whole topic, then we start. First is introductory part, then second one is thermodynamic potentials. In this point we will study about the 4 principal thermodynamic potentials. Then third one is Maxwell thermodynamic relations. Here we will study about the relations which depends upon the thermodynamic quantities like pressure, volume, temperature and entropy. Then next one is Joule-Thomson effect. In this point, we will study about the experiment of the Joule-Thomson's, which is depends upon the Maxwell thermodynamic relations. Then next point is Clausius-Clapeyron equation. In this point, we will study about the application of Maxwell's first thermodynamic relation. Then next point is expression for CP/Cv and Cp/Cv. Here we will study about the relation between constant pressure and constant volume. Then last point is TdS equation. TdS equations have 2 parts, first TdS equation and second TdS equation. So these are the all points we will study in this topic. Now we start our topic. We know the thermodynamic variables like P for pressure, V for volume, T for temperature and S for entropy. These are the basic variables of thermodynamics which are not gives us a complete knowledge about the system. Therefore, for complete knowledge of the system, certain other relations are required. Hence, we introduce some functions of these variables: pressure, volume, temperature and entropy, means P, V, T and S, and these functions are called as thermodynamic functions. Then next point is thermodynamic potentials depends on first and second law of thermodynamics. We get some functions of pressure, volume, temperature and entropy denoted by P, V, T and S respectively. For the complete information of the system, these functions are essential and these functions are known as thermodynamic functions or thermodynamic potentials. There are 4 principal thermodynamic potentials. First is internal energy denoted by U. Second is enthalpy denoted by H. Next one is Helmholtz function denoted by F, and last one is Gibbs function denoted by G. These are the 4 principal thermodynamic potentials. Now we study these 4 potentials in brief. First potential is internal energy. So what is internal energy? We know that the energy having lots of molecules, and every molecule have its kinetic energy and potential energy. So sum of the kinetic energy and potential energy of all the molecules of a system is called its internal energy. So what's the definition of the internal energy? The sum of kinetic and potential energy of all the molecules of the system is called its internal energy. So we know that from the first law of thermodynamics, dq is equal to du plus dw. dq is nothing but change in heat, du is change in internal energy, and dw is nothing but external work done. dw, the value of dw is pdv. So put this value of dw is equal to pdv in equation 1. We get dq is equal to du plus pdv. Then in next equation we just interchange the position. Therefore du is equal to dq minus pdv. This is the second equation. But from second law of thermodynamics, which is we are studied in last sem, dq is equal to tds. Therefore equation 2 becomes du is equal to tds minus pdv. That means internal energy means dq, it change in internal energy is depends upon ds mean change in entropy, and dv in change in volume. That means internal energy is the change with respect to entropy and volume. Therefore u is the function of S and V, means internal energy is the function of entropy and volume. So next point is, for an adiabatic process dq is equal to 0. We know that dq is equal to 0 is the condition of the adiabatic process. Therefore equation 1 becomes du is equal to minus dw. The value of the dq becomes 0. Therefore equation gives du is equal to minus dw. And what is the value of dw? pdv. Therefore du is equal to minus dw is equal to minus pdv. That is, change in internal energy is equal to external work done of the system, which depends upon the external work done. So this is the internal energy derivation part. Second potential is enthalpy, which is denoted by H. Enthalpy is the sum of internal energy and pressure volume product. Means what? Mathematically H is equal to U plus PV. This is the equation number first. Differentiate equation first. We get dH is equal to du plus d of PV. So what is the differentiation of product part? dPV is equal to pdV plus vdP. First constant, then differentiate the second term, plus second constant, differentiate the first term. Therefore dH is equal to du plus pdV plus vdP. We consider this equation number second. Then we know that du is equal to tds minus pdv. In the last equation we study that internal energy equation, du is equal to tds minus pdv. Put this value in equation number second. We get dH is equal to value of du tds minus pdv. Put in equation number second. We get dH is equal to tds minus pdv plus pdv plus vdP. Then in this term, minus pdv and plus pdv, both are same value with different sign. Therefore these two values are cancelled. So what we get? dH is equal to tds plus vdP. Let this equation number 3. That means dH is depends upon the value of ds and dP. What is the meaning of that equation? That means enthalpy is change with entropy and pressure. That means enthalpy is the function of S and P, which is the denoted by entropy and pressure. If the process is carried out at constant pressure, then dP is equal to 0. Constant pressure means the value of dP is equal to 0. Then equation 3 becomes dH is equal to only TDS, and TDS nothing but dQ. that is change in enthalpy is equal to the heat supplied at constant pressure. Means at constant pressure the enthalpy is equal to the heat supplied. Okay. Third potential is Helmholtz function. Helmholtz function is the difference between internal energy and product of temperature and entropy. It is also called as Helmholtz free energy. So mathematically F is equal to U minus Ts. U is the internal energy and Ts means product of temperature and entropy. So the difference between internal energy and product of temperature and entropy we give Helmholtz free energy denoted by F. Then differentiate this equation, we get dF is equal to du minus dTs. Again differentiate the product part, we get TdS plus SDT, but because of minus sign both value gets minus sign. Therefore dF is equal to du minus TdS minus SDT. Give the equation number second. But we know du is equal to TdS minus PdV. Put the value in equation number second. We get dF is equal to this du value, we get TdS minus PdV minus TdS minus SDT. So in this equation TdS plus TdS and minus TdS gets cancelled. Therefore dF is equal to minus PdV minus SDT. This is the second equation number third. That means Helmholtz free energy is change with volume and temperature. dF, F is Helmholtz free energy, dV means change in volume and dt means change in temperature. So Helmholtz function is the function of volume and temperature. For the reversible isothermal change, dt is equal to 0. Then equation 3 becomes dF is equal to means from equation number 3 minus SDT term gets cancelled because of dt is equal to 0. Therefore equation becomes dF is equal to minus PdV is equal to minus dW. That means Helmholtz free energy is used to perform external work. From equation 1 F is equal to U minus Ts. U is equal to F plus Ts. Here F is the Helmholtz free energy and Ts is latent energy. Okay. Therefore what is the definition of internal energy? Means internal energy is equal to Helmholtz free energy plus latent energy. We give the internal energy. So in this lecture we study the internal energy, enthalpy and Helmholtz function. What is the equations of the internal energy? du is equal to TdS minus PdV. Then enthalpy's equation is dH is equal to TdS plus VdP, and Helmholtz function is dF is equal to minus PdV minus SDT. So we get these three equations and these three potentials. The next part we will study in next lecture.